Yes, please.
Okay, I won't get started for a couple more minutes, but today, after I'm going to talk for just a little bit about geospatial data structures very quickly, and then we're going to jump into sort of a hands-on exercise. And you the platform that we'll be using is something called QGIS, which is available, if you haven't installed it already, as a free download at qgis.org. There are installers for both Windows and Mac, and it just takes a couple of minutes to install. If you haven't done that yet, I would recommend downloading the LTR release. And the installer should be pretty clean. Where did it go? Go down. There we go. So 3.44 is, or actually 3.40 is what they call the long-term version. But any version should work fine. There shouldn't be any changes that will have an impact on the work that we're doing today. And if you want, I did print out a couple of copies. It's pretty long. And I'll go through it step by step up on the screen. But if you want a hard copy, I have a couple more. Okay, anybody used QGIS before? Oh, I know you've used it. Okay, so I'll give a quick interview of the interface as well, and why we're using it today in a second. But I will have a few introductory words and just a couple of quick slides on geospatial data. So just very quickly, I won't go into my whole what GIS spiel is. It used to be an acronym. Yeah. Yes, that's me. I'm sorry. Yeah, that's me. I'm the GIS librarian here. Yeah. It is pretty loud. Yeah. That's good. I appreciate that. We'll see how long it takes to get hot in here. It's hard to tell, but yeah. So my name's Eric Glass. I'm the GIS librarian here, and yeah, I am the sort of resident official specialist in mapping and GIS tools. Although all of us play in those environments a little bit, I think. I also consider myself a geographer, along with Wei. If you come to my full normal introductory GIS class, we'll spend an entire session talking about what this term means. But for our purposes today, it's this sort of nebulous concept that takes place in the intersection of computing technologies and geography. And in this sense, I mean just basically the functional reality of things that have some sort of identifiable location on the surface of the Earth or relative to the surface of the Earth. And I'm not going to get into the nitty-gritties there other than for some data purposes, because we're going to talk a little bit about what is particular about geospatial data and a little bit about the structures. And we'll have another session, I think, on the first week of November, where we're going to dig in a little bit more into that structuring of the data, and really jumping into a specific, an emergent format called GeoPackage, which we'll see a little bit today, but at a very surface level. If you want to sink your teeth into it a little bit more, we'll do another session in a few weeks. A lot of people think about software when they talk about GIS. I'm not going to glean into that too much either, but for today's session, we're going to use a package called QGIS, which is a free desktop application which is specifically built to work with geospatial data. And has a variety of tools that are built in for working with data, organizing that data, and displaying that data and creating a map. And the workshop that we'll be doing today will sort of touch on all of those aspects. So we'll look at a few different types of data. We'll look at how to manipulate that in QGIS and how to take the manipulations we've done and display them relatively, to make a relatively appealing map, something that you might use for a research project, for example. QGIS is an open source application, so it's not just free, it is completely open. You can go to the GitHub repo and download the source code if you want. It is a platform that is built to be extensible. There are hundreds of tools that you can plug in that are extant from different places. Some of those connections are actually built into the platform. Others you can develop yourself or borrow from somebody else and plug in. So it's really more of a suite of technologies, some of which are as old as me, almost, and some of which are still in development. So it's very open sourcey. So it helps if you're a little patient. Sometimes things don't blend together quite as seamlessly as they would. And sometimes it's not as documented as well as you would like it to be, but it's pretty mature, and there are a lot of free resources. It's pretty widely used, and so it's pretty easy to find help for problems that you might have. There's a pretty big online community of users as well that will share that. So I'll show you a couple introductory things on that in a second. But before we do, I'm just going to talk a little bit about spatial data or geographic data or geographic information, which is, that GI part of GIS, right? And so spatial data can take a lot of different forms. And, there are unstructured forms of spatial data, some of which can be vernacular even, just references that you might say. But in a GIS context, what we're talking about today, we're going to be talking about something a little bit more specific, and what I'm going to call georeference data. So this is data that is imbued with coordinates, right? Numbers that specify a particular location on the Earth as derived from some kind of model of locations on the Earth. And I'll have a couple of words about that in a second. I'm not going to jump into data structures in a very sophisticated way, but there are a couple of components that we usually use the terms geometry and attributes to use when we're talking about spatial data. We usually make a distinction between the geometry, which are those coordinates, and the way that those coordinates and locations are actually organized in the data, and the attributes, which is everything else. So it isn't fundamentally considered to do with the actual location of the stuff that we're representing in the data. Traditionally, we refer to GIS data as layers, and I'll talk a little bit about why that is as well. But very quickly, I'm just going to emphasize that coordinates are derived from particular models of the shape, size, and systems of identifying locations on that model. So this is a map of this room. That red dot is where we're sitting right now. And if I look that up on Google Earth or whatever, it'll tell me that we're sitting at negative 73.95973 to the west and 40.807487 to the north. That's going to be very close to what your phone is identifying your location right now if you look at it. And that is all well and good. But those coordinates are based off of a specific coordinate reference system that is usually known as World Geographic System 1984. And that is a very commonly used model of Earth-wide locations. That is one that is typically used from GPS units, your cell phone, and websites. Web mappings tend to use that. But that is far from the only one, right? So in a lot of North American specific systems, you might see something like NAD 1983, which will express that same location with very slightly different numbers. Likewise, there are somewhat more involved systems, including things that we call projected coordinate systems, which are sort of geographic coordinate systems which are leveraged in specific expressions for map projections. And we'll look at one of some of the data that we're working in the workshop is in something called State Plane New York Long Island. And this is a projection system that is specifically for New York City in particular. And I won't go into the details or the whys of that, but locations in State Plane New York Long Island are expressed in linear units, usually feet. And the origin of the system is somewhere in Pennsylvania, such that all of locations always use positive numbers. You never see negative numbers. So there's no prime meridian that goes through Greenwich and State Plane, Long Island. So if you use a lot of New York City-based systems, you'll see state plane coordinates used a lot, and they're quite different. So the exact same location has very different expression in that. And there's a worldwide system of projections known as Universal Transverse Mercator. This is something you might come across in your work, particularly if you're doing international sites. And those also use linear units expressed in meters. And there's 72 different zones that you might use depending on what area of the world that you're mapping. So a lot of the time when you're doing GIS projects, in particular simple mapping projects, this might be obscure to you because one of the powers of QGIS and a lot of other tools is that this is handled under the hood. And most of the time, or at least much of the time, these systems are encoded in the data in a way which you may not even see if you don't know that it's there. But sometimes that won't be the case. And sometimes it'll be encoded incorrectly. You see that a lot too. And I get a lot of questions about people whose map doesn't look right. And one of the common issues is that you don't understand the coordinate system that your points come from. You can almost think if you have text and you don't know what language it's in. If you don't know the coordinate system, then you don't know where your locations are. And like as an example, if I took that first set of coordinates there and mapped them in GIS, but I didn't know the system that I used, and I applied the wrong one, this location would be mapped in significantly different places in some cases. So for right now, I just want you to know that this exists, and if it causes a problem, you might think around that as an issue. I've already mentioned projection coordinate systems, and that's really more a matter of the visual expression of these coordinates, right? So when we're interfacing with QGIS, it's usually on a flat screen. And so QGIS needs to have some sort of algorithm almost. You can think of that as to how to actually plot these locations. Like where do they go on the screen, right? It's one thing to understand like the conceptual idea of where they are, but if I'm representing those on the screen, how do I do that? And so geographers have derived hundreds and thousands of different strategies for doing this, and these are often referred to as projections. And some of you, probably all of you, have had some exposure to some of these. I think everybody has heard something about the Mercator projection at some point. Depending on the projection that you use, things can look and appear and behave quite differently, particularly if you've got like a world scale map. And that's why if you're using something like Google Maps to look at directions to the grocery store from your house, everything looks exactly as you might expect, but when you zoom out to see the whole Earth, things can be quite distorted. So any time that you visualize something in QGIS, you're applying a map projection. So it's really important to know how that works and what map projection you're using. And when you are actually producing work, to understand what type of projection is appropriate for that project. And that's a complicated question, or it can be complicated. And so if you have any questions or you ever want to talk about that, you can always reach out to me. I'm always happy to think around what's best for what you're doing. But I can show you at least how to set and adjust through many of these in QGIS, because again, one of the powers of QGIS is that it understands and can apply thousands of map projections right out of the box. Yep.
Why is the Mercator projection so popular?
That's a good question, and I can give you at least a partial answer, right? So let's, I won't spend too much time on this because we don't have that much time, but it's always fun to, no, Google Maps, right? I don't want Google Earth. Google Earth doesn't even have Mercator anymore. Does Google Maps have Mercator, or actually does something else? So if we zoom all the way out here, yep, okay. So we see all this tremendous distortion, in particular Greenland, which is absurdly large, right? So Mercator actually was a 16th century geographer from Central Europe. And his map projection, in large part, was designed to represent lines of constant compass bearing as straight, right? This was a long time ago. He wasn't working with a lot of information. And the fact that something very similar to the projection that he made still works very successfully for navigators today is quite an accomplishment. But he didn't do that specifically to make this distortion, but that's basically the purpose of the map, right? So a line of constant compass bearing will be represented as straight on here. So if you want the shortest path from one place to another, this does a pretty good job of telling you what that is as the crow flies. It's not particularly good for looking at maps like this. So why does Google use it? This is an example of what we sometimes call a shape preserving projection, right? So the shapes of things look good even if the size and distortion is not so good. And most of the purpose of this is not to like look at the whole world, is to look at your neighborhood. And you can go to any city or any place or any neighborhood anywhere in the world and zoom in, and it looks nice and neat because it's a shape preserving projection. So it's very nice for most of the purposes that Google Maps is for. It's just not good for that, you know, stretch out view. That's the simple answer, right? You have anything to add? You're looking at me like I'm...
I mean, yes, but...
Yes, right. So there's a lot that we could say, but that's a diplomatic answer, but it's an honest one, I think, right? So that's a good question, though. I'd be happy to do a data club on map projections. That'd be a lot of fun, right? So individual data sets in a geospatial context are usually referred to as layer. So, that's sort of... It's sort of technological because this was originally sort of like the spatial ontology that was derived with these systems, which actually leveraged the predecessor to GIS applications, which were big folios of translucent sheets that land use planners would stack on top of each other. But usually when we create spatial data, we do it with this idea of normalizing the data type into discrete data sets which are encoded and designed in this fashion, where individual data sets have the same type of phenomena, that have the exact same type of geometry and attributes, as I said before. And then if you want to look at different types of phenomena in the same location, you work between this stack of layers. This is also visually how things appear in QGIS. Like as a QGIS user and you look at the map screen, you're actually standing on top of the earth looking down through this set of layers, and you see the first layer first and so on and so forth, right? And so this is the standard GIS data image that I'm legally required to show you. You can find a million different versions of that, but we'll see how that functions in QGIS here. So very quickly, I'm just going to talk in a very broad way about the two most important types of data representation in GIS. I usually call these like families of data models, which are vector and raster, right? Those are the two catchwords that you'll see when people talk about GIS data. We're really only going to look at vector-based data in the workshop, and I can show you one or two raster data sets. But basically, these are the two primary ways of representing and encoding data in a spatial data set. And both have distinct ways of modeling both the geometry and the attributes. Vector data, the representation, the most important thing to know is that the representation is at what we sometimes call the feature level. So in a vector data set, your data is encoded in such a way that it's seen as a collection of discrete phenomena, where the geometry is derived from one or more of these coordinate pairs. So a vector data set is basically a collection of discrete phenomena, which we usually call features. And those features all have the same geometry and the same attributes. And the geometry is usually, well, it's almost always a point or multi-point geography, takes up no space, a line geography, which is two or more coordinate points that are logically arranged, and also doesn't have an area, or a polygon geometry in which you have three or more logically oriented coordinate points that do define some area. And we don't tend to mix and match these geographies in the same data set, right? So all of the features in a vector data set will have the same geometry, and they also have the same attributes. And in vector data sets, the attributes are typically stored in a two-dimensional table, right? Where they all have the same columns, which are the type of attribute, and each feature will have a row in this table. So this is a vector representation of neighborhoods in Japan, and the attribute data is data from the Japanese census. So this is a data set that we've licensed. And for every neighborhood in Japan, we've got hundreds of individual datums about that neighborhood. How many people live there, how many are men, how many are women, what it's called, how many children they have, what they do for a living, on and on and on. So this can be a pretty robust way of collection, of bringing together a huge database of information about discrete phenomena that have some sort of spatial arrangement. And this is obviously a polygon geometry. All of the neighborhoods are represented by an area that don't overlap. They're entirely coincident, and that is also very typical in these vector data sets, is that they do not usually allow overlapping geometries. And even when they do allow that, if you do it, it will tend to break a lot of the analysis tools that we use in a GIS context. And then the contrast to that are the raster models, in which space is typically represented by a matrix of squares, where each square represents some designated area, and that area has some value that's associated with it. Typically just one value. That's the most common way to represent data in a raster format. The best known example, or the most widely known example, are photographs, right? So photographs are raster representations where the value represents some color, right? But we also represent all types of data spatially in GIS. A classic example is elevation, and this is a very small part of an elevation model that has a raster representation. We call that a digital elevation model, or DEM. So each one of these squares represents 30 by 30 meter spots somewhere, and there's a value which is the elevation above sea level, or estimated elevation above sea level for that area. And so at the top left there, that's got a value of 124 meters. And so this is actually a map of a very steep hill going down to the water. This type of data encoding and this type of data model is pretty widely used for data like this that can be represented as a continual surface of values. It'd be that color, elevation, weather, temperature. Most weather maps are raster representations. And sometimes they're used for qualitative data as well, particularly land cover data. I had just downloaded a land cover data set, which we can look at because there's no raster data in our workshop. Okay, so that is my 20-minute geospatial data intro. We'll actually look at this a little bit. If you've installed QGIS and you open up the desktop, it should open up looking something very close to this. I might still have a couple of extra tools installed on mine that you don't have, but it should look pretty close, right? So this is the basic platform. There will always be a big empty window here. That's the map window. If you don't see that, then you haven't opened QGIS. There will be some selection of toolbars here at the top. Most of these are turned on by default. You can see which toolbars you have turned on under the View menu, which these are the ones that I've got installed. You may have slightly fewer, and if they're checked, then they should be turned on, and by default they'll be docked at the top. You can move all these around. There are also these so-called panels. I think when you install this the first time, you get the same thing that I have here, the browser panel and the layers panel turned on. You can see those under the View menu as well. Panels, there are a variety of these that I'll turn on sometimes when I'm working on a particular project, but you almost always want to have the browser panel and the layers panel turned on. And I usually keep them docked to the left, which is how it came installed for me. But you can also move these around as well. The layers panel is where the data that you're working with will appear. We'll see that in a second. The browser panel has a lot of connections that you can build to. Both on your computer and also to build connections to services elsewhere. One example is you can build connections to web mapping services, which they've labeled down here as XYZ tiles. It's sort of an awkward name, but I believe when you install this, it'll come pre-installed with a connection to OpenStreetMap. That's a Google Map-like service, which is all public domain data So the OpenStreetMap project is kind of like the Wikipedia of maps, and you can build a connection to that. And you can see this. This is actually a raster representation of the Earth, right? So it's basically just a series of map images. And if you zoom in close enough, you'll see that there are individual pixels here. And the representation, again, is just color as it would be in a photograph. So that's the basic interface. Let's see here. I always build you can navigate to anything that's on your local desktop. You can connect this to a remote drive if you use a remote drive for your work. I always just build a connection to the directory for the project that I'm working on. So if you right-click on favorites, you can add a directory. And I just added the download files that we're using on my desktop here. And so I can just click on that, select a folder, and build a shortcut to all the data files. So this is what's in that download directory that you can access very quickly from here. Okay. The most important tools here are the map navigation tools. You always want those turned on. We'll use those in a second. And I am sure that this Open Data Source Manager and these data creation tools should also be turned on as well. And then this toolbar up here should come pre-installed as well. I can't remember what it's called, but these are basically, these are the tools that you can't really use QGIS without having them accessible. There are a variety of other tools that are available through menus. Some of the ones that will be important, most of the most important geoprocessing tools are docked in these vector and raster menus. They decide which are the most important and arranged here. I actually never use these pull-down menus because I cannot configure what any of these categories mean or how they decided to put these in here. So two things that I think everybody should know is that you can access any geoprocessing tool through the processing toolbox. So if you go to the processing menu and open toolbox, these are all of the pre-built-in tools and scripts that you can use to work with spatial data. We'll use just a couple of these today, but you can access all the ones that come pre-built in here. There are also hundreds of external tools which you can plug in automatically through a plugin manager, and that's under the plugin menu here. If you click on that, you can see these are just hundreds. It's not a complete listing because not everybody opts to have their tools listed here. But many of the most commonly used external tools that other developers have made are available here. And there are a few of these that I almost always keep installed on mine, like QGIS and some of these search clients. And so you can read about those. Most of these have documentation. There are hundreds of other developers who make tools for QGIS that they don't go through the process of having them available through the plugin manager. Typically, they'll be posted on a GitHub repo or their website or something like that. And if they set them up correctly, you can install those very quickly through the plugin manager as well. We're not going to be using any plugins for this workshop, which, in addition to having a printout over here, if you downloaded from this link, there should be a PDF. It's pretty long in terms of links because I've tried and given you every step by step. In case we can't do everything today, you've got everything that you need to do this. All of the data that you need for this is available for free download, and there are detailed instructions on how to do that. There's some data cleaning that's involved, and I've given you instructions on how to clean the data as well. But as a shortcut, I've actually given the downloads directly in that download file as well. So if you click in here, everything that you need is available in here, and you don't have to actually do any data cleaning. But I think it's a good exercise to have all of that information available. Because that is part of the process, right? Even when you're going to resources which are designed to provide data for you for exactly this type of use, it's very rare that it's going to end up in a format that won't have a lot of tension, right? There's tension there. And so I'll probably skip around that as well. If you'd like to follow along with me, I'm just going to go through step by step. If you want me to stop, just let me know. But basically, the purpose of the workshop itself is grabbing some free public data and creating a map. And the map is a representation of fireworks complaints from this 4th of July in New York City by neighborhood. I live in the West Bronx, right, which is like the fireworks capital of New York City. And when I came up with this assignment, I thought that that would be a useful exercise, right? So does everybody here know the city's 311 system? Right, that's the non-emergency complaint line that's been around for about 15 years now. Every complaint that is lodged to 311, I think not the ones that get forwarded to the 911, but all the actual legitimate 311 calls are logged continuously on the NYC Open Data Portal. And it's got locations usually down to the intersection. And so you can pick like whatever particular type of call that you want, and you can map them. And so we're going to do that. And we're going to try and see how many of these there are in different neighborhoods in New York City, and then also get the population for those neighborhoods and see what the complaint rate is, right? And it's important to think that this isn't exactly a map of fireworks activities. It's a map of fireworks complaints. So I can't really say how well of a representation of fireworks it is, but I can say it should be a completely accurate representation, or almost perfect representation of 311 fireworks complaints by a neighborhood in New York City. So how are we going to do that? Well, first we have to decide what a neighborhood is. And that's actually a very complicated question too, and we could spend hours talking about that. So I'm just going to tell you. We're going to use one of many potential neighborhood delineations that are known as neighborhood tabulation areas. And these are designations created by city planning. And what they are aggregations of a different neighborhood type called census tracts. So I assume most of you have heard of census tracts before. These are the neighborhoods that are designed by the U.S. Census Department as part of some of their surveys, particularly the decennial census itself and another survey called the American Community Survey, which is what we're going to use. And they're usually neighborhoods of around 3,000 to 5,000 people, which in New York City is a very small area, sometimes as small as 2 blocks. So this is a map of the census tracts in the Columbia area. And you can see one neighborhood just down the block, there's literally only 2 blocks is a neighborhood for the Census Department. Now these change from time to time, and they don't have any particular meaning for the residents themselves. Most people couldn't tell you what census tract they live in. They don't have any cultural understanding, let's say, right? And so NTAs are an attempt by city planning to put together these census tracts in a way which does have some sort of meaning for residents of New York City. So where we are is in the Morningside Heights NTA, and that's an aggregation of 8 of these census tracts such that it looks like this, which tries to conform to like the understanding that we have of what Morningside Heights would be. And so they've done this throughout the city. These neighborhoods tend to have populations that are more in the 40 to 50,000 person range, and they tend to be around the same population. So if you've got like a neighborhood that's really big, like Harlem, for example, there are 2 or 3 NTAs that represent Harlem. There's like Central Harlem and North Harlem and Hamilton Heights and so on. But they're aggregations of tracts so that you can still use the census data at these neighborhood levels without having to do any sort of estimates beyond the estimates that the census has made, if that makes any sense. And so we're going to use that, and we're going to build these NTAs using tools in GIS, right? So what I'm going to do is have us grab a census tract file And the census tracts are derived by the U.S. Census Department, but then the City Planning Department takes those definitions, those geographies, and it changes them. It makes their own file. They trim the tracts down to the New York City coastline, and then they add some of their own data, including the appropriate NTA code for each of these tracts. And we've taken that data, and we've made some changes of our own, and we've made it available through our library catalog, and you can download it directly there, and if you want. But I've also got it in this folder that's named CUL_NYC_tracks_2020, right? So these tracks are usually remade every 10 years to coincide with the decennial census and then used for that whole decade. So even though it's 2025, we would use the 2020 files. The Census Department provides these in a variety of formats, but most commonly in something called the shapefile format. We'll talk about shapefiles a little bit if you come to the session in November. But for right now, that's probably, just know that it's probably the most commonly used vector format in GIS. But we're going to use something called the GeoPackage, which is an open and newer format that has some advantages over the shapefile, not the least of which is that it keeps all of the data in a single file, right? So it's a little easier to work with if you've never done this before. And so I'm going to add that into QGIS, and there are a couple of ways that I could do it. I've already showed you how to make a connection in the browser panel, and if you do that, you can expand to it and literally drag it in the map window. That's usually what I do because it's the easiest, but you should also know of at least one other way to do it, and that is the data source manager. One of the most important tools in QGIS is this open data source manager. You can make all sorts of connections to all sorts of data from here, but you have to know what type of data it is first. I know that this is a vector representation of neighborhoods, and so I'm going to click on the vector menu, and then I'm just going to navigate directly to that file. It's got the GPKG extension, it's the GeoPackage extension, and so I click on that, and I click on Add, and then Close, and this is it, right? So this is a map of all of those census tract neighborhoods in New York City. It's a vector representation, so each one of these neighborhoods is defined by some number of coordinate points. Usually, if you zoom in a little bit, you can see exactly what they are. Some of them only have 4 of them, and this looks like one right here. You can tell there's a coordinate here, there's a coordinate here, there's a coordinate here, there's a coordinate here. It's a connect the dot puzzle, right? And so each one of these tracks, they don't overlap. They're entirely coincident, right? The people that make this make sure that there's no slivers in between. So every place in New York City is in one tract and only one, right? But they have trimmed it off so that you can see all the nice islands here. If you want to see the attributes for this, now when I added this to my map window, it automatically went into the layers panel, right? So the layers panel is the most important panel. You always keep this turned on, and this will list all of the data or layers that you have. Right now I just have the one, and you can see I can toggle it on and off visually by this checkbox here. There's a lot of right-clicking if you're a Windows user, or double-clicking if you're a Mac user in QGIS. It's not required that you use a mouse, but it's extremely helpful if you're actually working on a project to use a mouse. So I got to remind you of that. If you right-click on the layer in the Layers panel, you can go to Open Attribute Table, and you can see the attributes here. You can also highlight it, and probably you should have this toolbar at the top as well, and you can open the attribute table as here. And this, I usually undock the window. These are all the attributes for each one of those tracks. It's not very useful. It's mostly a series of names and IDs that we don't need to use. It tells you what borough it's in, the census numbering code in a variety of different permutations. We won't get into that too much. I will tell you that there is a column here called the GeoID. This gives this is the full name of the census tract. So this is the name according to the Census Department. Just like you have a zip code, your census tract has a FIPS code, and the full version of the FIPS code is an 11-digit number for the tract, and that is important because that's the data that we'll need if we want to assign some other information to there. Importantly, city planning has also added the NTA name and ID for that neighborhood, for that tract, right? So each one of these tracts is in one of these NTAs, and that NTA name is something like 2 letters and then 4 numbers. But they also have a vernacular name, which they've assigned so people know where it is. So this very first tract, and I'm going to click on it over here and select it. It'll highlight it in blue in my attribute table, and then if I look in my map window, it will also highlight it in yellow. Nobody lives that one, so let's pick the second one. This tract right here, down by the Brooklyn Bridge, they're calling this neighborhood Chinatown 2 Bridges. I think there's another Chinatown in here as well. But the real name is MN0301. So Manhattan, that's basically the real name. But they also have a vernacular name for this so that people actually make some sense to people that are familiar with New York. I'm going to, sorry, I keep docking this accidentally. I'm going to deselect that. So there's a button up here which turns off my selection. And you can interactively select and play around with these as well. So there are some selection tools, and again, these should come pre-docked at the toolbar. And you can use these to, if you want to know what neighborhood this is, you can highlight them in the map window, and that'll select them in the table. And then you can see that this is parts of Lower East Side, Tribeca Civic Center, East Village, and so on and so forth. Yep.
So how did you open that?
This table? Yep, sure. Let me do that again. I'll deselect. You can right-click on here and go to Open Attribute Table, or you can highlight it in the Layers panel and hit this Open Attribute Table button at the top, and this will bring this up. Now, there's no information in here about fireworks or people, right? So that is what we're going to have to add. So there's 2 big things that we need to do. First of all, we don't want census tracts. We want the NTAs. So we're going to combine these into the NTAs. And we want to get the population of these neighborhoods, and then we want to get the number of fireworks that is in each neighborhood. So the first thing we're going to do is get the population data, right? Now these tracts are actually designed for that very purpose. That's the fundamental purpose of them, is to get the data from the Census Department. So if you go to the instructions here, there are a variety of places that you can get demographic data from the Census Department that you can match up with these tracts. There are basically 2 surveys which use data at this tract level. The best known one is the decennial census, which is the full enumeration of the population. And it would make sense for us to use the 2020 population enumeration for this. But there's another survey called the American Community Survey, which is an ongoing survey that also calculates and estimates the number of people in each of these tracts. But they also collect a vast variety of other data. Data about the people that live in those tracts and the housing in those tracts, right? If you ever get an ACS survey, has anybody got an ACS survey? This is like a 30-page questionnaire. You can go to their website and look it up, and I always make my students do this before they work with the data, just so that they have like an understanding of the actual survey tool. But they ask you all sorts of questions about everybody that lives in the household, as well as the housing that you're in. That data is available down to the tract level. They're estimates. This is not a full enumeration. Only about, I should say only, but about 3 million households a year are surveyed. So it is by far the biggest annual survey in the country. And you can get the data freely from a variety of sources. These instructions have you go to the census website and do a query to just get the population estimates for 2023, which is the most recently available set. 2024 estimates will be available probably in a few weeks. That will take a few minutes, but it's worth doing this if you want to be familiar with this. We have a number of other resources that you can access this information from, and we have a research guide that's available on the RDS website, which has some recommendations for that. But this is a website that's freely available to anybody in the world. And so you just need to assign a few queries. You tell them that you're looking for census tracts in New York City. You'll have to pick all 5 boroughs, and then you want the total population. And then you download it, and then you'll need to clean up the data a little bit. That would take me about 10 minutes to do here, so I'm going to skip it and just tell you that in the download file, there's a CSV table that I've named Population 2023. And what I've done is I've eliminated all the data except for 2 columns. The population column, which is the estimated population for that tract, right? And you can see some of these are 0 because some of these tracts are delineated in places where people don't live. But most of them will have a population that'll typically be in the 3,000 to 5,000 range. That's the most common thing that you'll see. And then this FIPS column is that 11-digit identification code that we mentioned earlier, right? So it's basically like the name of the tract. You got to jump through some hoops to get here, and keep in mind these are estimates; they're not the full census enumeration. But we can join this into our geo package because this designation should exactly match up with that GeoID column that we saw in QGIS. And now I've saved this as something called a CSV. That's a comma-separated table. That's a text-based version of encoding tabular data like this, which is pretty common. If you're not familiar with that, it's not the same as an Excel spreadsheet. So I'm using Excel right now. If I save this, by default, it saves to an Excel spreadsheet. You can read those into QGIS, but I recommend that you don't. CSVs will generally play better. And it also makes us tied to keeping this in a 2-dimensional table with just one row name that represents the column names, and everything else is the data. Keep it simple, basically, is the rule. So I'm going to go back to QGIS, and I'm going to add that table into my map document. And here it will be much nicer if I do use the data source manager. Clicking and dragging might not be so clean. This is not a vector data set. In fact, it's not a spatial data set at all. A CSV is a type of delimited format, a delimited encoding. So I'm going to click on the delimited text button, which is identified with a little comma here, because that's the most common type of delimiter. And I'm just going to navigate to population 2023, and I'm going to add it. Now, sometimes we encode spatial data in these tabular formats, and we'll do that in a moment, actually. But this data set doesn't have any geography, right? There's no coordinates in here. So I need to tell QGIS that there is no geometry in here, because it will assume perhaps that there is. And I'm going to say this is just a table. But one thing that's not so obvious is that it guesses what type of data each of these columns is. And because both of these are numeric, and they're both integers, there's no decimals in any of these columns, it assumes that they're both integers. That's actually not correct, right? This FIPS code, while it looks like a number, is really more akin to a name, right? It's actually what we would say is conceptually a qualitative data, right? And so I'm going to make sure that it gets encoded as a string or a text field. There are 2 reasons for that. One is that it's correct, right? It just so happens that all of the tracts in New York State start with a 3. But if it was Alabama, they'd start with a 0. And if I imported this as a numeric code, QGIS would then ignore that 0, because that's not how integers work, right?
But that also, you need to make sure the leading 0 is defined as text in the Excel file.
Exactly, yeah. It would be the same case if we were using an Excel file. And I can tell you, because I already know this, that in the geo package, that GeoID code is correctly encoded as text as well. So even though QGIS will read this correctly if I bring it as an integer, it won't be able to associate those two fields together. And that's, again, another common headache that people tend to have. So I'm going to just make sure that it's text. I'm going to give it that instruction. I'm going to click Add, and I'm going to close this. There's nothing to map here because there's no geography, but it still gets added as a layer. By default, it will become the first layer. If you want, you can also open this attribute table and inspect it just to make sure that it still looks good. And that's all well and nice, but we don't need to do that. So what I'm going to do is I'm going to add in that population data into my geography by linking it up with that GeoID code that we saw before. And just as a reminder, if you open this attribute table, this GeoID field, which is a text field, is exactly the same. And if you click on this button here, well, that's a different one, but you can actually see in the data itself, it's aligned to the left, right? That's actually a visual indicator that it's encoded as text. And so you'll learn to start looking for that. These are numeric columns, which you can tell because they're right justified, and these left justified columns are encoded as text. And that's not an accident, right? That is the appropriate thing to do it. So because there's one entry for every tract in my geography and one entry for every tract in my table, we can do what we usually call a table join. And in QGIS, the easiest way to do that is in something called the layer properties. So if you right-click or double-click on any layer in the layers panel, the bottom option will bring up a huge variety of properties for that layer. And there's a lot of very useful tools in here. But we want to use the joins tool, right? And so this is, we can build relationships between different layers we can build tabular relationships through different layers by using this joins tool. And so I'm going to click this little green plus, add new join. I only have one option here because it's the only other layer in my project right now. So it's population 2023. And I want to make sure I pick the two fields. So in population 2023, I labeled it the FIPS field. But in the geo package, it was labeled GeoID, right? So I click on those two. I would recommend clicking on custom field name prefix and deleting this because by default, for some reason, it now adds a prefix to my new columns, which I don't want. It's not a big deal, but it's annoying to me. So I'm going to click on this and then make it blank, which is a little counterintuitive, but that's how they have it set up. And I'll click OK. And now when I open the attribute table again, I should see that population field over here on the right. And I usually scroll up and down to make sure it looks like everything filled out, and this looks appropriate, right? So this is great. Now I can map and run calculations on this population field. Now this is like GIS, QGIS best practices. Once that relationship looks successful, I want to encode that permanently in a new derivative data set. So when we do projects in here, we're constantly creating new and derivative data. Even if you don't think that will be something that you need permanently, it is a good practice to do that immediately. Because right now, that relationship is just held in QGIS memory. It's very tentative. And there are a number of things that could cause it to break or get lost, and then you'd have to go back and do your work over again. And the easiest way to do that in QGIS is to export it to a new geo package, right? The easiest way to do that, again, is right-click, double-click on the layer name and go to Export and save features as. Now, one thing I forgot to tell you when I first opened this, it's in the exercise, but I'm not actually reading it, is that when I added this, geography here, the coordinate system and the projected coordinate system are appropriately encoded in this data, like I told you about earlier. And so QGIS automatically was able to read that data. It's in the geo package, and it's in something called New York State Plane, which we talked about at the beginning. And that's identified in this little corner at the bottom. And you can actually click on this, and it'll give you all sorts of details about this. Because it's the first data set that I opened in this project, it made that projected coordinate system the visual system that this project is arranged in. Now, if I add in other data and other coordinate systems, it's going to adjust it to fit this current view. But if you want to change that, you can do it through this dialog here, right? We'll come back to that in a little bit. But when I'm exporting my data, so I'm going to export save features as, features meaning my tracks. QGIS gives me a bunch of tools that I can use to sort of convert the data, right? So I don't have to export this as a geo package. These are a variety of other vector-based formats that also play well in QGIS, including the shapefile, which we mentioned already. But I'm going to keep it as a geo package. And if I wanted to, I could change the projection. I could reproject this into a different system. So this is a very quick and easy way to do that. You will have to do that in your own projects. I'm taking that out of this for right now. I'm going to keep it in state plane, but this is an easy way to do that. Now I've got a directory here I called Scratch, and this is where I keep the files which I don't think that I'm going to need permanently, right? And I recommend getting into the habit of having a directory for files which you think will be intermediate files. Sometimes those will end up being files that you keep. But most of the time, you want to have like a home for them so that they don't pollute the rest of your working directory that you think that you will need. That will become a big issue when you're working on more complicated projects. So get into that habit now. And I'm going to call this whatever I said to call it in here, which is tracks with population. Very sensible. This actually isn't the best name. I could have picked a different one. Usually I will do something like tracks NYC 2023 with population. Just put all the information in the name, but I would recommend not using any spaces in there because I'm old. And click OK. And this is going to look exactly the same, but if you look in the attribute table now, you will see this column is now permanently encoded in here. There's no tenuous relationship here. And it will be completely fine to get rid of these previous data sets. We don't need them anymore. Easiest way to do that is to right click on them and go remove layer, OK. And same with the table, remove layer, OK. Now, we don't want tracks though. We want the actual NTA neighborhoods, right? So we want to actually bring in all these tracks and meld them together if they belong to the same NTA. In GIS speak, we usually call that a dissolve transformation. That's a term you'll see a lot. You're going to dissolve these tracks into NTAs. And there are a variety of tools in QGIS which will allow you to do that.
I have a
Yeah.
question.
Mm-hmm.
When I create the G package, I do have the -SHM and -WAL. I didn't see on your computer.
Let me see what.
So when I create this, I will get the two other. And the same thing when I drag the G package, the original layer.
Oh, you dragged it?
Yeah. They
What I would
also-
do,
okay.
use the export dialog. So right click,
Right.
on
This
it.
one?
you know, in the layers panel there. There you go.
Here.
Yeah, double click.
Okay.
Okay. What's the menu pull down for this? Do we know?
Do command click. Wait, that's it.
Okay, yeah.
Yeah, you got it. Export. Yep.
Yeah, yeah.
Save features as. There. Use this one. Yep.
Yeah, the same thing I did here. And when I export, I get 3 files.
Are you getting 3 files?
Yeah. So,
What happens when you click the big file in? Because I'm not sure what it's adding.
so this is just to, like I save as whatever, like test, right? Save it. And if I click OK, save on my download. And you see, on my download, they will automatically create the other 2.
I don't know what those
Yeah,
are.
so that's weird.
Okay, I'll figure that
No,
out.
no problem.
But just use
I
the,
just want to know this is weird.
Okay, I don't know what that is yet, but I will figure it out. But I think probably if you add the large file, it should work. Sorry about that.
Yeah, I think it's my own problem.
Okay, so we're going to do the dissolve function. And now there's a dissolve tool that's actually in the vector menu. This is actually not the best dissolve tool to use, and we'll have much better results if we use one that's hidden in that processing toolbox that unfortunately is not called dissolve, it's called aggregate. So if you type in aggregate or start to type it, you should get this tool called aggregate. So aggregate is it's a tool that will allow us to do a dissolve transformation that gives us a lot of tools to determine how to do that dissolve transformation and how to adjust data. Yeah.
Those two files are intermediate files that are being used to guarantee ACID transaction in writing your data, the database, so you can delete them. The
Okay.
SHMN wall.
So it's kind of the hidden files that
Yeah,
Yeah.
somehow
sort
I
of
can
hidden
see.
files, yeah.
You probably have some setting on your computer that
Okay.
reveals
yeah,
them.
Yeah.
Yeah.
Or only for Mac machine? I don't know. I have
You
no
can
idea.
delete them.
Yep.
Okay.
Thank you.
Thank you.
Okay, so we're going to do this dissolve by an expression. And it's going to be a very simple expression. I just want to dissolve based off that NTA code, right? And that NTA code was named NTA 2020. So that's the actual name of the NTA. And what this is going to do is it's going to say, if it's got the same NTA code, combine them together. But I want to do something else, right? I want to keep that population data and I want to sum up the data, right? So if you scroll down to the bottom, you can see it's got that population field, and these are all the things I can do with it. And when the option that I want to pick is sum. Now it's guessing what I want to do, and sum is the guess, and so that's correct. But you know, sometimes you might want to take the average or some other calculation. But this is the important part. Most of the rest of these fields we don't need, and I like to keep things clean. So if I was doing this myself, I would delete all the fields that I don't need. The only thing that I want is the population field, the NTA code, and the NTA name. The rest is just clutter. So this is optional, but if you click on the top line and then click on the one right before NTA name and hold down Shift while you do it, it'll select them all. And if you click this little button on the side that says delete selected field, it will just get rid of those. Now I want to keep the NTA name because I want to know what the name of the NTA is. And I'm just going to pick first value. Now these should all be the same, right? Because I'm only keeping ones that are the same. So I could pick the first value or the last value or something else. It's all going to be the same. And the same for the NTA code. I can just pick the first value. And then I can also delete the rest of these. Again, it's not necessary, but if you want to keep things as clean as possible, I only need these three codes. This is going to create a new geo package. And so I want to make sure that I'm going to save that into my Scratch directory, and I will call that I can't even read. Expate, toolbox, NTA population. Great. All right, magic. That's what NTAs look like. And you can see here, we should get something that looks like Morningside Heights. There are a couple of weird artifacts in here. That's the city planning's fault. I'm doing this for illustrative purposes. We could fix that if we had more time. But they made a mistake in this latest version, which I wouldn't have known if I hadn't done this. But that is a little bit of a slipper. But now if I open my attribute table for this, you can see all we've got is a single entry for each of these neighborhoods, each of these NTA codes, and a population is the sum. And now you can see the numbers are much bigger. They're typically more around 50,000, right, for each of these neighborhoods. All right, so we're halfway there. Now we need to get our fireworks complaints, right? Now, I'm going to take a shortcut for this as well. If you actually look in the instructions, I've got detailed instructions on how to do this. You go to the city open data portal, which is a great website with thousands and thousands of data sets from all city agencies. One of the most commonly referenced ones is the complete log of 311 calls since 2000. It's like 15 years old, there are millions and millions and millions of these, like tens of millions. You do not want to go there and download the entire table, right? But you can query it directly in the website. And so what I said is I just limited the complaints to between noon of this July 4th and this July 5th. And then I set a limit for a complaint type that contained the word fireworks. And I think all of these are encoded as illegal fireworks complaints. So there might be a couple other weird ones. If you do it as I did it, you should get about 4,000 for this year. There were about 4,000 in a 24-hour period on the 4th of July, which was a manageable amount to export. I originally was going to do all of July, and there's a lot of fireworks complaints in New York City, let me tell you. So that will take you a few minutes to do because it's a huge data set. But when you're done, you should get this table with 3,888 approximate complaints. And it's got tons of data on each of these calls, including the longitude and latitude in decimal degrees, right? So this is important. All of the coordinates in the NYC Open Data Portal are in that WGS 1984 system that we talked about at the beginning. So they're like GPS units. They're not in state plane coordinates. We can change that in a minute. But because this is a vector data set. It's just a CSV, but this is a vector GIS data set where the geometry is defined by a single point, right? And QGIS can read this as it could read a geo package. Again, you wouldn't want to click and drag this from the browser panel because that won't work quite right, most likely. So I'm going to go to my data source manager, and I'm still going to click on delimited text, even though it is a vector arrangement. It's still encoded as a CSV. And I'm going to click on that table. And now I am going to say it has point coordinates because this does have a geometry, and I tell it where the X field and the Y field are. Now it guesses based off of the column name, and because the columns are labeled reasonably, it will probably guess correctly, but you do have to make sure that the X field is the longitude and the Y field is the latitude, and you have to tell it what the coordinate reference system is. Because that is not encoded in this table. You have to know what it is. I'm telling you, it is in WGS 1984 because I know that. But if you don't know that, then you might have some trouble. And it's guessing that because that was the last name that I used, most likely. But if it doesn't come up as the guess, which it probably won't, you can either click on this little icon here. It looks like the Earth is wearing a small conical hat. And then you can search through the predefined CRSs either by using a keyword search, WGS 84, or more precisely, there is a code, a worldwide code system which specifies that specific projection. And that one is code 4326. And someday you'll have that memorized, most likely. So you'll click on that, click OK, click Add. It might ask you about what type of transformation you want to make. The reason it's asking you that is because our project is using the state plane coordinate system. It's not using WGS 1984. It doesn't really matter which one of these you pick right now. I'm just going to pick the first one, and you may not get this dialog box depending on how your QGIS is configured. But I have that turned on. And you'll see now it maps every fireworks complaint in the city directly on those, even though it's a different reference system. And you can see, just looking over this, that there's definitely some clustering in northern Manhattan and the Bronx and parts of Brooklyn. And then there are some open spaces, either because there are no fireworks there or because people don't complain about it, right? So I can't really tell you why that is. But these are the complaints that they got. I would again recommend immediately that you export this to a formal GIS format, specifically GeoPackage, right? Because right now we're just visualizing that CSV. It's not in a geo-referenced format. So I'm going to export, save features as. I'm going to make it a GeoPackage. I'm going to save it again in my Scratch directory with the name. NTA FW, nope, that's the wrong one. FW locations, right? So firework locations. And now I would generally reproject this data, right? Since my project is in state plane, I would prefer these locations to be in the state plane system. There are many reasons to do that beyond just the tidiness of it. But some geoprocessing tools may not play nicely if you're working with data in different projections. I think we would be okay for what we're doing, but there are other tools that might not work quite right. So I would strongly advise you to try and make sure that all of your data is in the same coordinate reference system, unless there's a good reason for it not to be when you're working on a project. So I can just quickly reproject it by picking which one I want. It gives me a list of the ones that I used most recently, so I'm just picking it from there. But again, you could come here and look up New York, Long Island, and you'll eventually get that system. Click OK. Again, it will look exactly the same, but now I have a geo package that's in a different projection. If I want, I can remove the CSV that I added. I can also remove these tracks because I don't need them anymore either. Not going too fast? Okay, so the next step is I want to know how many of these complaints are in each NTA, right? And the most sensible way to do that is to do something called a spatial join, right? So we did an attribute-based join before, or a table join as I called it. But now I'm going to join these data sets together. I'm going to join the information together based off of spatial arrangement. And this is the simplest type of spatial join that you could do. But there's very complex types of relationships and transformations that you can do using this type of process. But in this case, all I want to do is know how many of these points are in each one of these neighborhoods. And there are a number of spatial join tools that come pre-built into QGIS. But there's one very simple one, which I think is hiding in what they confusingly label the analysis tools, which is count points in polygon, right? So this is very simple. It just says, if you've got points and you want to know how many of them are in your different areas, this tool will do that for you. And since it's all I need to do, I will use that. So I'm going to pick NTA, my NTAs as my polygons, obviously, and I'll pick my firework locations as my points. I'm going to change it's going to give me a column that gives me the total for each one of these, and I'm just going to label that column fireworks. And I'll name the output to my Scratch directory as NTA FW totals. Great. So again, the output looks just like the input, but when you look at the attribute table, you can see now it has the total number of fireworks complaints for each NTA. So that's pretty cool. And now we can map this if you want. But I said we wanted the actual rate, which is why we got that population figure. I just don't want to know how many fireworks complaints there are in the city. What I really want to know is what is the rate of complaints in the neighborhoods, right? And so we need the population to normalize that. Now, one of the most useful tools in QGIS is something called the field calculator. And you can access this both from the top menu bar here, but if you're in the attribute table, it will be docked at the top. It looks like a little abacus. This will give us pretty sophisticated tools that will allow us to make and edit data just in our attribute table, right? So this is non-spatial calculations. And I can create a new column directly from the field calculator. And so what I want to do is make a new column that gives me that rate, right? And so I open this up. I'm going to click on Create a New Field. by default, it wants to create an integer field, but because this is going to be a proportion or a rate, I really want it to be a decimal number. 0 and 3 should be fine. And then I need to build an expression. And I can build a calculation using data directly from my table. Yep.
So all the work that you're doing right now, it'll add the rate to your attribute table, right? But not to the map necessarily.
It won't map the data. That's the next step,
Yeah.
right? This is right now, I'm just working in the attributes. I'm not working in the geometry, and I'm not working in the visualization of the data. So I'm just going to do this very quickly. I'm going to add 2 parentheses, and within those parentheses, I'm going to say I want to take the fireworks and divide it by the population, and then multiply that by what? I put 1,000, right? Okay. So very nicely, there's like the center menu, which gives you a number of scripts and tools. But there's one that's called Fields and Values, and that allows you to access all of the columns in the table. So I need to make sure that I'm spelling everything correctly, so I'm just going to double click on fireworks. And it'll take the fireworks column. I'm going to click divide by population. This is going to give me a very small number, so I'm just going to multiply it by 1,000, and that'll give me the rate of complaints by 1,000 people. You can also do 10,000 or whatever. So fireworks divided by population in parentheses divided by 1,000. It's going to create a new field called fireworks, which I forgot to put it. No, wait. FW rate, sorry. Called FW rate, which will give me the rate of fireworks complaints per 1,000 people in that NTA. So I click OK, and there it is. Some of these are 0. Most of them are less than 1. If you click on the column title, it will actually sort them. So you can see that in Inwood Hill, which is the fireworks capital of New York City, there are 142 complaints per 1,000 people, right? So quite a lot. Now let me deselect. When I did that, I'm actually editing my data. Now QGIS usually protects you from editing the spatial file itself. You can play around, but it won't usually let you edit the data. In order to do that, you have to enter something called an editing session, which you have to instantiate yourself. However, the field calculator has special privileges, right? So it will actually start an editing session without you knowing it. So I just make sure that everything looks right, and then I'm going to detoggle my editing session, which is this little pencil tool. And now I hit save, and so that will actually save my changes. And now I can actually map that data itself. And so what we usually will do again are the layer properties. So I want to symbolize the data from one layer. So I'm going to use the data property. So I right click on my layer and go to properties. And I go to the symbology tools. And this actually determines what this layer looks like. So this current symbolization is random. Like if you're following along with me, you probably got a different color or something like that, because it just randomly picks a color. I can assign any color or pattern that I want. Or I can assign some sort of rule-based symbology. And that's what I want to do. I want to graduate and change these colors based off of that value that's in that column. So I'm going to pick graduated color schemes based off of the FW rate. And there are some pre-built-in color ramps that you can use, or you can build your own color ramp. I'm just going to pick the green color ramp. This is what I use in the exercise. And then you can classify or batch these data into classes that are meaningful for you. So you can manually choose these chunks, or you can use one of their preset algorithms for doing this. The default setting is something called quantile classification. What that will do is it will take, depending on how many classes you choose, so I'm going to choose 5 classes, and it'll say, I'm going to set the class size such that about 1/5 of the neighborhoods get into each of those classes, right? And so if I hit classify, you'll see the class ranges vary considerably on the size of them, particularly because this is extremely right-skewed data. The first class is just zeros, and the last class is from 0.57 to 142.86. But if you hit apply, you'll see what that looks like. A few of these are missing because there's no data. So I'm just going to click this off right now. But you can change that scheme. There's documentation on what all of these do. When I did this for the exercise, I used quantiles and then I changed them such that this one was just 0. This one went to 0.25. I just rounded off these numbers a little bit, right, to 0.5, to 1, and 1 and above. You can play around with that until you get sort of like the distribution that you want, right? I'm out of time, but there's like actual step-by-step instructions on taking this out into the visual map composer component of QGIS, so that you can refine this, add your map elements, and then export it in a format that you could use for your paper or project. Right? So that's the quick map making interface. And if you want to talk to me more about this, reach out. You can reach out to the group, or you can also just reach out to us at data@library.columbia.edu. Thanks.